I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, May 10th. Tonight we'll be discussing jet stream roller winds, surface level pressure, significant wave heights, and all the things that go into making surf in the North Pacific Ocean. Let's get to work. Looking at significant wave heights for the South Pacific Ocean, we see a broad gale in play, generating seas at 34 feet, aimed pretty well to the northeast, with a secondary area of 29-foot seas, aimed better to the north, and filling a large portion of the South Pacific. This system has been in the water for several days now, and has generated swell, and that swell is pushing northeast. So, things are looking pretty good at the moment. As usual, we'll start tonight's tour looking at jet stream level winds in the South Pacific Ocean. It is pretty much close to the summer now, so our main focus is on the South Pacific, but that does not mean that that is the only hemisphere that is in play. The North Pacific is also still active, believe it or not. All right, but as usual, we're looking at jet stream level winds. These winds up about 30,000 feet help support the formation of gales. When those gales form, it helps direct their track. We're looking for a trough, a push to the north in the jet stream, like right there. Now, this is an interesting situation because the jet's actually falling south over New Zealand and into Antarctica, but there's this trough that was actually free and clear. There wasn't this clutter down below it a day, 2 days ago or so. And so it's still supporting gale development, and it is actually merging with the northern branch of the jet stream, producing winds at about 170 knots over a small area. So we'll give it some credence for the moment. But anyway, so this troughs like this help form a clockwise flow in the upper atmosphere, and in the southern hemisphere, that's the hallmark of low pressure. And of course, down at the surface as well. And low pressure, if it's strong enough, generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, turn into swell. Swell, when it hits your beach, turns into surf. All right, so we have a trough in the, we'll call it the upper reaches of the central South Pacific. And that trough is supposed to hold on to some degree even into Monday. And then, look at this, getting a little bit more energy as we get into Tuesday, but the apex of the trough starting to move out of the Southern California swell window. It's about 117 west, 118 west, somewhere right around in there. You'll see the center of the, oh, look at that. Actually, it kind of back builds a little bit. Interesting, but not a whole lot of wind supporting it. We're not sure that there's really going to be any additional support for gale development at this point. And you notice a big ridge building across the southern hemisphere, across the South Pacific, pretty much cutting off whatever was left of that trough. You see it starting to fade out here as we get into Wednesday night, and then it's all but gone. So ridge takes over, pushing under Tasmania here, pushing south. When you get the split jet stream flow, like one there, then typically you get high pressure in between. That doesn't do anything for generating storms or swell production. We're into Saturday night, almost a week from now, Sunday, another ridge pushing south. No clear evidence. We'll go out just a little bit further. Nope. No clear evidence of any support for gale development the coming week in the southern hemisphere. But do not be dismayed. The good news is there's two swells in the water, one of them starting to hit and another behind that. All right, let's go take a look at surface level pressure, surface level winds. And here we are. Here is our current low pressure system. It's barely a gale, 35 knot winds aimed to the north here. They call it a complex gale when you have these sort of multiple centers or multiple vorticities going on, all rotating around each other. But 35 knot winds to the north, almost 40 knots aimed off to the east. And that's pretty much the main focus in the southern hemi. We'll put this into motion. You see as you get into Monday, the secondary fetch pretty much collapses. 40 knot winds aimed off to the east on Monday, and then that slowly fades out. Notice this, a little secondary fetch developing 35 knots. It's really not strong enough to do a whole lot, but aimed well to the north, you get maybe, I'm just eyeballing this, I'm guessing 24-foot seas, 23-foot seas. That's like a 13 or a 14-second period. That doesn't survive too well pushing off to the north the whole way up to California, but who knows? Maybe something could result. That continues into even Wednesday night, then it finally fades out. Remember, the trough collapses then too, and that's it. A ridging pattern builds in the upper levels of the atmosphere. Let's see if that manifests itself down at the surface, and sure enough, there's your high pressure. There's all your storm energy aimed pretty much southeast as we get into Saturday and Sunday. A little bit of a gale there. Interesting. Let's see. No, not really strong enough winds. So pretty much a zonal flow. There are systems forecast, but all tracking off to the east, not aimed up to the north. No swell generation potential looks likely given what we're seeing here. But let's go take a look at the wave models. Now, before we get into the forecast, we're actually going to go back in time. A week ago, there was a gale. This is the last little part of this gale. There was a gale that actually developed under New Zealand, kind of was weak, tried to blow up a little bit over the South Central Pacific, then finally got its act together to some degree in the East Pacific. This was Saturday, a week ago. Energy from this swell is starting to hit California on Sunday. A lot of it's being masked, though, by a northwest swell that's hitting at the same time from the Gulf of Alaska. But anyway, as you see, Sunday a week ago, the gale continued, producing a little area of nearly 40-foot seas, 39 feet over a tiny little area, 30 feet here, broad area 29 feet or better. Look at that, continuing into this was last Monday morning, then it faded out. So that is the swell that is hitting now, going to continue for Monday, Tuesday, Wednesday, maybe even into Thursday of this coming week. And then another system, you can see it building under Tasmania last Wednesday. There you go, 35-foot seas. Pushed under New Zealand, sort of build up a little bit to 39 feet on the Great Circle Pass to Hawaii, California, and other places down in Central America and South America. Now, it tracked under New Zealand, but look at this, a broad area of 29 to 30 to, we'll say, 31-foot seas, solid, and just watch this thing slowly just plowing across the South Pacific. Not a high seas, but a broad area of fetch, just pushing. So that's good in terms of just having a good number of waves in a set. And the other good news is it was all aimed pretty well off to the northeast, so smaller swell expected for Hawaii. The lion's share of this is expected into California. You see it continued on to, we're in Saturday night, now we're into Sunday, still just, okay, well actually let's go back. So from there, that's 600, 1,200, we'll say 1,100 nautical miles of seas at 26 feet or higher with pockets at 29 to 33 feet. That's pretty solid. That's certainly better than no surf at all. So that gets us to where we are right now. Let's go take a look at the forecast. So here we are. Now we know the system's supposed to kind of fade out, move off to the east, turn more zonal, target mainly Peru and Chile, and that's it for swell generation aimed at California. Now we just go out through the rest of the week. We're into Wednesday night. Not a whole lot going on. Looking for anything. You see there's activity under Tasmania in that area, but it doesn't make it cohesively into the South Pacific unless the models make me a liar. Nope, and there we go. Also notice the ice line building further to the north now. When we've about a month ago, it was down below 70 south. Now we're at 66, 67, and up to almost 64 right there. So as we get deeper into the southern hemisphere winter, the ice, our Antarctic ice, starts building to the north, starts reducing the amount of area here in the southern hemisphere where wind can get traction on the ocean surface. It's got to be ice-free, right? You got to have wind blowing on the oceans, generating seas if you want to get swell, and ice basically is the same as land, just locks it all down. All right, so nothing for the next week. So let's go take a look to the north, and here's the interesting thing. A little low forecast off California as we get into Monday, generating, what's that, maybe 14 or 15 foot seas. And that's not really our focus, though wind swell from the west is expected for North and Central California. But look at here. We're at May 12th, and another little low is forecast developing off of Kamchatka. Not huge, not big, but anything at this point is good with 20, we'll call it 23, maybe 24 foot seas pushing over the date line with 25 foot seas over a decent size area, and then falling southeast into Wednesday, still 25 foot seas into Thursday, and then fading north of Hawaii with 21 foot seas, and then gone by, we'll say Friday, something like that. Still, if this materializes, it certainly looks like some swell could be pushing into Hawaii. Well, you can literally see it right here on maybe Friday night. And energy pushing to exposed breaks in North and Central California into, we'll say Saturday or so. And look at that, actually some degree of the gale. Let's roll this back. So what is that? That is 15 foot seas. Yeah, 15 foot seas holding. I mean, so that'd be like, 11-second period, something like that. Energy on top of whatever was generated when the gale was out here. So north swell for next weekend. And we know that there's going to be southern hemi swell hitting at the same time. So again, it's kind of this dynamic of, well, would I want the north swell or do I want the south swell? If you got a spot that's exposed to both of them, most of the times that kind of just makes for a very jumbled sea state. And the waves don't really join together and amp up. They tend to sort of just warble each other out. Anyway, so let's keep going. We'll go out till the end of the week, 180 hours out, supposedly some tropical activity off of southern Japan. We'll believe it when we see it. Though warm water down in here, if there's warm water in the Pacific, that's probably where the bulk of it is. All right, let's move on. All right, potential for wind swell for Hawaii and the U.S. West Coast. Low pressure, Sunday midday, off of California, generating 25, click away there, almost 30 knot winds aimed towards the coast. And that's supposed to continue. Oh, look at that, 35 knot winds as we get into Monday and 30 knot winds. And then fading out. That's what's generating 15-foot seas. So wind swell pushing into the California coast, probably just eyeballing it around Tuesday, Wednesday sort of thing. And then southern hemi swell hitting at the same time. We're looking for Hawaii. We're looking for trades greater than 15 knots over solid area. Not seeing it. So all the wind swell potential, at least at this point, looks targeted for California. As we get into Wednesday, then things settle down. A little bit of north winds off of Point Conception, but here comes the next low pressure system. We saw that on the models, so that's going to cut the legs out of any high pressure, pretty much reducing the odds for wind swell, local wind swell production potential. But this system in and of itself will generate swell for Hawaii and into California if it develops as forecast. And then you see, we'll get into Saturday. It almost looks like a front right there, pushing up to the coast on Saturday, at least the North California coast. And where are we here? We're out to Sunday now. Secondary low, tertiary low out here. Interesting. Seems like sort of a late season push. Oh, and then finally some fetch, supposedly a week from now, starting to set up along the east shores of the Hawaiian Islands, maybe some tiny wind swell at best. Let's go take a look at precipitation potential. So here we go. The low off the coast, generating some rain, pushing into, we'll say, Northern California, north of the Bay Area on Monday midday, and then down to Monday afternoon, the whole way down to Santa Cruz, and then falling apart there. Maybe some rain, maybe a little dribble of snow for the highest peaks in the Sierra. Rain continuing mainly north of the Bay Area into Tuesday. And then another little secondary pulse with basically the same area targeted again north of the Golden Gate on Wednesday afternoon. And then it looks like maybe high pressure taking over. We'll see. Let's roll this out. Nope. A little bit more rain for, say, Cape Mendocino on Saturday night. Oh, down to the Bay Area on overnight on Saturday. And then falling apart quickly. Rain for the Sierra. And then more rain on Sunday for Cape Mendocino, maybe down to Point Arena, and then we're 180 hours out. It wouldn't be unusual to maybe see a little dusting of rain, not dust, that would be snow, but a couple of showers maybe down into the Bay Area again from this. So the rain is not completely over, though. No significant rainfall expected. The hard dividing line, pretty much Monterey Bay, but even at that, probably north of San Francisco. All right, let's go take a look long term. What's going on with the Madden-Julian oscillation and El Nino or La Nina? So first up, we start looking for the presence of the active phase of the MJO. When in the active state, the MJO helps impart energy to the jet stream, which in turn then helps feed the storm track. The connection is strongest in winter months in the North Pacific, but the active phase, if it's strong enough during summer months, can also help feed storm production down under New Zealand and across the South Pacific. All right, so the MJO is a periodic weather oscillation, runs for about 4 weeks. It runs the whole way around the planet, going from west to east, only on the equator, and it takes about 3 to 4 weeks to get across the Pacific. First the active phase for 3 or 4 weeks, then the inactive phase for 3 or 4 weeks. Of course, the active phase helps feed storm production. The inactive phase tends to dampen it or tamp it down a little bit. All right, so we're looking at winds. This is from the TAO buoy array, a series of buoys strung across the equator. This is the equator here. This is the far east Pacific here. This is the far west Pacific here. That's New Guinea. Date line right there. So we're just looking at the arrows. The colors are water temperatures. East winds pretty strong over the East Pacific, over the Central Pacific, and then into what we call the Kelvin wave generation area. This area from 5 degrees north-south from 135 east, the far, far west Pacific to 170 west. Just this side of the date line. A box right there in your mind. When you get the active phase over this area, and if it's strong enough, and if it takes these trade winds and tamps them down, or actually reverses them, and if there's warm water here, then you can get a Kelvin wave formed. That is, warm water in the West Pacific starts sloshing to the east, not on the surface, but underneath the equator. It takes about 3 months to make the traverse the whole way across the Central Pacific, and then it erupts off of Ecuador if it's strong enough, and then it can create a warm pool off of Ecuador. And if you get successive Kelvin waves, that can be how you kickstart El Nino. All right, but right now, we're not seeing any sign of the active phase of the MJO. If anything, we're seeing the inactive phase. Let's take a look at anomalies. So these are the actual winds, but it's the difference from normal for this time of year that's really key. We're just looking at the arrows. We see a little bit stronger from the east in this area. You see the arrows coming from the east. So neutral in the far east equatorial Pacific, but in the central Pacific, maybe a little bit stronger east than normal. Then over the Kelvin wave generation area, pretty much normal. So not active phase, not inactive phase, just kind of a dead MJO signal, at least according to this. Let's go look at the forecast. All right, here we go. So this is a different style chart. Whole planet on one chart. This is zonal wind anomalies, the east-west component of the wind. If you see blues, that means the winds are stronger out of the east. You've seen yellows, stronger out of the west. Active phase of the MJO typically produces west anomalies. That's what we want in terms of imparting energy to the jet stream and producing Kelvin waves. So here's where we are today. This is past performance. In the Kelvin wave generation, well, the Kelvin wave generation area, Pacific starts at about 135 east, so go right up there. And the Kelvin wave generation area ends at 170 west. Ecuador is at about 85 or 80, I believe, so right up around there. All right, but what you generally see here is for the whole month of April, easterly anomalies, inactive phase of the MJO. Here's where we are today. Easterly anomalies and a little bit of westerly anomalies, sort of a neutral thing. But going for the next week, looks like east anomalies return, inactive phase, in control firmly. And though we didn't say it before, well, just like if you have successive strong active phases of the MJO, that can help generate El Nino. The same is true with successive inactive phases of the MJO of decent strength. That can help generate La Nina. All right, so what are we looking at here? This is a model that goes out 2 weeks. Outgoing, where is it? Right there. SOLR, outgoing long-wave radiation. Fancy words for cloud cover. If you have yellows and oranges, like you sort of have there very weakly over the maritime continent, that means less cloud cover than normal. It means high pressure, and that's pretty indicative of the inactive phase of the MJO. If you have blues, then it's the more cloud cover. That's sort of like low pressure, and that's the active phase of the MJO. So just eyeballing this, no MJO signal present in the Pacific for today. Going out 5 days, no signal. Going out 10 days, no signal. Going out 15 days, no signal. This per the statistic model. The dynamic model pretty much says the same thing. No MJO signal for the next 2 weeks, though an inactive MJO is supposed to be building in the Indian Ocean about 2 weeks out per the dynamic model. Then let's go look at phase diagrams. These tell you where the strength of the MJO and where it's positioned, the active phase of the MJO. So assume you're looking down on the North Pole. The MJO travels from west to east on the equator, from the Indian Ocean over the maritime continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, and back to the Indian Ocean. So round and round. Wherever the active phase is, the inactive phase is on the other side of the planet. Now, right now, according to this, the heavy dot is where the active phase is, so that would say it's probably somewhere in the far East Pacific, and the further the dot is out in this area, away from the circle, the stronger it is. So the active phase in the East Pacific, extremely weak, and forecast to maybe track east into the Indian Ocean, but still just being very weak. This per the statistic model. Dynamic model says the same thing. The short answer is basically no MJO signal for the next 2 weeks. All right, let's go out 3 or 4 weeks. 40-day model, upper level model. So this is consider it potential for rainfall. So where the greens are your areas favorable for precipitation, and that is like the active phase. So there's South America, Central America, active phase. In the far East Pacific, there's the equator right there, date line there. Inactive phase in the far West Pacific. Inactive phase taking control of the Pacific, supposedly starting the next couple of days, making its way across the Pacific into, we'll say, June 10th or so, as the active phase pretty much moves out of the picture. Then a active phase, not a strong one, a weak one, again, develops in the West Pacific, the end of May, and makes its way across the Pacific in June, while another inactive phase builds in the West Pacific. And here's a month-long model, CFS model, 850 millibar wind anomalies. Again, the east-west component of the wind. Here's where we are today. This is the whole planet on one chart, Kelvin wave generation area between about here and here. That's where we're really interested, because that's where the fuel for storms originates. And today, weak west anomalies in the Kelvin wave generation area. That's good, but you notice they only last for about 2 days. Then you see the blues, easterly anomalies setting up, just taking control of the Kelvin wave generation area for the next month. Also notice this purple right here. Let's go up. This is the low pass filter. Purple, dotted, the dotted line suggests high pressure building in the Kelvin wave generation area. Now let's go back to February and March. You see it was a low pressure bias in the Kelvin wave generation area. If we went from that, and you know how generally bad the surf was in January and February, and now we're going to a weak high pressure bias, that's not going to do much to support storm development. Now let's be clear, that doesn't preclude storm development. You can't go, there's going to be literally no surf. No, that's not true. I mean, this is just the MJO and these sorts of macro level weather patterns. They sort of push the jet stream in a general direction, but there's always heat, there's always energy in the atmosphere, storms form, but they might be more sporadic, not as strong, not last as long, and therefore your total net number of swell days and the size of those swells for the season would typically be less than if the opposite were true, that if you had a strong low pressure bias in the Kelvin wave generation area. All right, let's go out even further. 3 months. This is the CFS model, 850 millibar zonal wind anomalies. A whole planet on one chart. Kelvin wave generation area from there up to about there, the whole way up. And then the Pacific ends somewhere over about that line there. And so this is past performance on the bottom here. The forecast is at the top on this chart. You can see the yellows and oranges, active phases of the MJO, westerly anomalies. You see how we moved from that sort of a regime to the blue easterly anomalies starting to show up and just eyeballing up here without even looking at anything. You just go, I see a lot of easterly anomalies setting up starting about June 10th and beyond, and that typically is the hallmark of La Nina. So let's overlay the MJO, see if our guess was pretty good. All right, so we are currently in the inactive phase of the MJO, this dotted contour, that's what it is, with a weak active phase forecast developing supposedly now into about the end of May. But you look and you see yellows and blues, sort of a mixed wind anomaly pattern. And then a weak inactive phase develops after that from May into, about late June or so. But easterly anomalies start building, even with the active phase of the MJO setting up late June into mid-July or so. East anomalies in the Kelvin wave generation area. You see westerly anomalies here, but they're all over the maritime continent or into the Indian Ocean. And then you see even broader easterly anomalies building as we get into July. Again, this is concerning. This smells a lot like La Nina. So let's overlay the low pass filter. Here we go. All right, so last winter we had low pressure bias over the Kelvin wave generation area, with a high pressure bias over the Indian Ocean. So if anything, we were sort of predisposed towards El Nino. And if you look at the surface, ocean surface temperatures in the equatorial Pacific, they definitely were El Nino-like. It just wasn't enough to get you pushed in for the atmosphere to respond like El Nino. We know last winter was pretty much a dud. But all the signals suggested that we were supposed to be in this not El Nino, but weak, warm state, and one would have thought we could have eked out a normal winter. Well, we certainly didn't. Now, what's even more disturbing here, you see the high-pressure bias supposedly starting to build June 27th in the Kelvin wave generation area, while the low-pressure bias that just as of today was in the Kelvin wave generation area, West Pacific, is supposed to move into the Indian Ocean. Again, looking like a signal towards La Nina. All right, enough MJO talk. Let's get into the El Nino La Nina discussion, see what the ocean thinks is going on. Okay, first off, looking at the TAO buoy array, series of buoys strung across the equator, used for monitoring El Nino. This is the East Pacific here, West Pacific here. These are the anchor lines on the buoys. The X's are the sensors on those anchor lines. You use that, take the data, send it up to a satellite, bounce it down to a central computer, apply a model to it to fill in all the gaps in between. You get a profile of what the surface temperatures look like. So, subsurface temperatures look like. So typically during La Nina, you get cold water building in the East Pacific, and all the warm water starts building up over here in the far West Pacific. During El Nino, the warm water that's here starts sloshing in the form of Kelvin waves off to the east, building a deeper reservoir of warm water at the surface here. Okay, during La Nina, the warm water almost disappears and all you have is cold water. All right, so right now we're seeing 30-degree isotherm, 30 degrees centigrade, that is, so that's pretty warm water. In the far West Pacific, tiny. The 29-degree isotherm, I think last week it was at 180. It's backtracking a little to 176 east. 28-degree isotherm, almost all summer. Winter, it was aligned around 160 west. It is backtracking too, while the 24-degree isotherm is getting progressively shallower, meaning, in just looking at this, meaning that whatever warm regime we were in appears to be taking a hit at the moment. In fact, here's anomalies, differences from normal for this time of year. Last week when we looked at this, we had warm water going the whole way across the, from 100 meters up in the across the equatorial Pacific. that's quickly getting eroded. A big pool of -3 degrees centigrade anomalies is pushing towards the surface. This looks like classic how you get the start of a La Nina sort of cycle, is this sort of thing. The Kelvin wave generation area, you could have west anomalies here, but any warm water that's here isn't going to make it very far because this cool, stable water pattern is pretty much going to block it. And we already know the MJO is extremely weak. There's no real west anomalies. There's no hope for Kelvin wave development. So it only seems reasonable. I mean, we've been going for a couple of years here with a pretty healthy Kelvin wave cycle in play. So it only makes sense that at some point the system collapses and we go cold for a little bit. How cold we get, how long it lasts, that's the unknown. Here's another model, same data, but you get the sense even here that the warm water, and this one lags a little bit behind the other one, but you get the sense, yeah, there's some warm water here, but you can see it's just getting carved out, eroded by cold water pushing up. This is actually a previous upwelling phase of the Kelvin wave cycle, not part of this initial cool pool here, but the net effect is the same. Warm water quickly getting erased. Warm water still holding in the far west Pacific, though. Sea level anomalies, all right? So that's South America there, Central America there, Mexico. There is the equator. There's the date line. There's New Guinea there. What are we looking at? This is JSON-3 satellite data. Strip out all the waves, strip out the wind waves, strip out the tides. We're looking for a bumper or depression on the ocean surface, just 5 degrees north and south of the equator. This is where Kelvin waves would be. If you have positive anomalies, that means that you have warm water at depth. It expands a little bit, creates a little bump on the ocean surface. So 0 to 5 centimeter positive anomalies in the far west Pacific. But you see this whole area off of Ecuador, over the Galapagos right there, the whole way out to almost the date line, -5, -10, -10. So this suggests we have cool water under the equator, just like what we saw in the model. So this is just confirming it. Cool water contracting, creating a depression on the ocean surface, and there you go, your -5 and 10 centimeter anomalies. Upper ocean heat anomalies. All right, so this is the West Pacific here, East Pacific here, and you can literally see Kelvin waves migrating or trying to migrate across the Pacific because we have the time factor on here. So last May, June timeframe, we had a Kelvin wave. It stalled, though. It wasn't very strong. Another one in July, stalled. Those generated by the active phase of the MJO, but it was a weak, both were weak active phases, didn't provide enough momentum, and we ended up with this sort of cool pool building in the summer. We thought we were going into La Nina, and then somehow, miraculously, we got lucky as we get into September. A decent active phase of the MJO set up, creating a Kelvin wave and warm water that pushed the whole way across the Pacific. And then we had another one in the November-December time frame, and another one in the January-February time frame. We saw that on the previous charts. 2 active phases of the MJO created a Kelvin wave, didn't quite make it to Ecuador, made it, south of somewhere off of Mexico, and then stalled there. But still, it created warm anomalies on the equator, and we'll see that in a minute. But now, it's pretty obvious. You can see cool anomalies building, and here is last summer's cool. Well, we were in, what was that, in May? Okay, so up here at the top, that was last summer's cool anomaly pattern. This summer's cool anomaly pattern, much more pronounced, much broader in coverage, suggesting that perhaps La Nina is trying to get a jump on things. All right, sea surface temperatures anomaly. Differences from normal for this time of year at the ocean surface. All right, so typically, if you want to see El Nino, you'd see warm water. Here's Central America, South America, Ecuador, somewhere right about there. There's Galapagos. You'd see warm water building up in this area. And you do see a fair amount of warm water north of the equator, but on the equator, and this just developed a week ago, cool anomalies setting up the whole way from south of Mexico almost out to the date line. So this sort of suggests that the warm water transport machine is getting shut down, that winds are blowing harder than normal out of the east over this entire area, creating upwelling. And we know for a fact there's that cool pool down below. It's not to the surface yet, but when it gets to the surface and it starts interacting with east anomalies in this area, then these temperatures will probably drop even more. All right, now we do see warm water north of the equator. This was that warm signal that we've been seeing all winter that sort of made us think we were like in, not El Nino, but like a weak warm pattern. This is leftover warm water. We think this blue cool water pattern is a trend or what the harbinger of what's to come as we get deeper into summer. Now, the one bit of good news, this is the sea surface temperature trend for the past 7 days. Last week when we looked at this, the temperatures were cooling pretty significantly out in this area, and did it the whole way through the week, and just in the past 2 or 3 days, that's completely collapsed. Now, we do see weak cooling off of Peru here, but in general, there's some sense that maybe warming is starting to set up, but we think that is just a temporary lull in the action. And the only thing that really matters here is on the equator. The official El Nino monitoring region is 120 west, 5 degrees north and south of the equator, out to 170 west. The 7-day trend says neutral, trending cool. And then in the Nino 1.2 region, it's just sort of a noise region, but it's kind of fun to watch. Generally a cooling trend there as well. And then the backed off view. Again, warm water. The leftovers from El Nino along, out and off of South America, Central America, Mexico. But again, that cooling tongue starting to develop. We're not guaranteed that we're moving to La Nina, but it sort of smells like it. And then we're just coming out of the spring unpredictability barrier. Now, the good news is, if it was some major La Nina, we would have seen signs of it already in February and March. Yeah, we kind of saw it in the atmosphere by not a whole lot of precipitation and the storm machine being kind of weak. But we never saw any cool water, so it's starting to develop just now, just maybe. We'll see if it holds. Temperature trend in the Nino 1.2 region. This is the area, again, right off of Ecuador and the Galapagos, that area. The trend, you can see it has been steadily downward. Today, up a little bit, 0.2 of a degree, 0.216 above normal. El Nino is half a degree for 5 consecutive months. Again, this is a noisy area, though. It really doesn't matter. It's the Nino 3.4 region that we're more concerned with. The temperature trend has been was sort of building into March and April, but is crashed as of recently. Dead even, minus 0.007 thousandths of a degree. We'll call it even. So, dead even, not towards La Nina, just a mix of the El Nino-ish warm water and this cool pool thing we're watching that we're calling kind of La Nina-like. All right, what does the atmosphere think we're doing? All right, one way you can tell is by using the Southern Oscillation Index. This chart here, difference in pressure between Darwin, Australia, and Tahiti. When the index is positive, that suggests you have higher pressure over Tahiti, lower pressure over Darwin, and that's a sign of La Nina. If it's reversed, lower pressure over Tahiti, then it's a sign of the active phase of the MJO and maybe trending towards El Nino. Today's contribution, pretty much neutral, 2.55. And you go back and you look, and it's been toggling around, hovering, you get negative for a day or two, but then you were positive for a day or two there. So it's a very noisy index, but just eyeballing it, say, pretty much neutral. 30-day average, 1.10. And what has it been? Well, it was at minus 6.74 a month ago, and it's been steadily moving more towards neutral, if not more towards the inactive phase sort of signal, but not much. 90-day average, minus 2.91. What were we a month ago? Minus 3.7. So, again, pretty much neutral. No clear sign in the atmosphere. Let's go take a look at just chart this out. All right, so here we go, 30-day moving SOI. So let's see, this was this was 2 summers ago, sort of La Nina-ish, neutral-ish, and then 2019 in the summer, it actually moved towards El Nino-ish, even though the water temperatures looked like La Nina. Now, today, we're moving towards, we're about dead even, neutral, neither El Nino nor La Nina, just rebounding from that sort of weak El Nino pattern that we were in towards neutral. So what's the forecast? Looking at the CFS model For sea surface temperature predictions for the Nino 3.4 region, the official El Nino monitoring region, in April, we were in the, this is again this past winter, kind of warm regime, not El Nino, but warmish. And then the model said temperatures were start plummeting in April. They didn't do that. It wasn't until May that it started. But as of right now, we're about right on track where we should be, dead even. And according to this model, it says we should be down at, by July, half a degree below normal, which is the beginning of the threshold for La Nina, and then holding the whole way through winter down to about minus 3/4 of a degree. Now, the interesting part is this is half as bad as it was a month or so ago when this model was saying temperatures would be down at minus 1.5 degrees. So this model was predicting doom and gloom. The closer we get to actually being in the core of like the summertime outside of the spring predictability barrier, this model's sort of rebounding some. Most models are saying somewhere hovering around neutral or just below neutral. This model's still biased on the cold side. If we can get up to, right now, what's it saying? Minus 3/4 of a degree this winter. If we can get it to minus half a degree and it rebounds a little bit more, then we're not even in La Nina. But still, it seems like the atmosphere is definitely primed to not certainly be super energetic, not be super conductive to storm development, not having lots of warm water in the East Pacific. And so this generally suggests a drier pattern coming for California. Less storm development, less snow development, at least in the southern tier states. Go further north, could be wetter, could be snowier, but we're talking December, January, February, so months and months from now. So who knows? It's a guess, though. But for the immediate short term, there is good news. Southern hemi swell is in the water and going to continue for the bulk of the work week. And as soon as that one's over, another one's supposed to be right behind it, producing probably another 4 or 5 days of southern hemi swell. So, hey, a lot of surf potential. And that's not even counting, or that's completely discounting the fact that the models are also saying another gale is supposed to develop in the North Pacific and traverse that and produce some northerly swell. So, looks like a pretty good situation. A decent amount of swell for the coming week or so. Let's make the most of it. Long term, not seeing a whole lot from the southern hemi, but you know, the models they sort of do that. They'll get into a funk for a while, and then all of a sudden one day you'll look at it and bam, they'll predict something that wasn't there for a week or two before it. So it pays to actually watch the models. All right, beyond that though, long term, I mean, we're singing the same old song, right? Cool regime setting up. Probably not a lot of support for storm development long term. Possible La Nina, but the models are sort of backing off a little bit. Maybe it won't be as bad as was expected, and it's still 6 months or more off, so who knows. But we're not getting our hearts too set on an epic winter or fall coming, but, you know, you never know what it's going to be. All right, so if you enjoyed the video, hit the like button. If you have not subscribed, please subscribe. Just down there, hit the subscribe button. The bell will pop up. Click that. You'll get notifications when we do new updates. Of course, we typically do it Sundays, so you can just tune into the channel and come see it. Otherwise, go to stormsurf.com. All the model data, everything is there. And we do post links for the videos weekly when we do them. All right. Thanks for watching. Stay safe. We'll see you next week. Same time. Same channel.